Hello dear students, we are again back in the calculation of uncertainty, and this time we are going to calculate the uncertainty for the third category as we mentioned earlier in our first video of the uncertainty. This is multiplication category. So here is a question where it is stated that a mass of 2 kg is accelerating at a rate of 2 meter per second squared, and this mass and acceleration both are stated in terms of their absolute uncertainty. So what we have to do is we have to calculate the magnitude of this accelerating force with its uncertainty. So we have to calculate the force and we have to calculate the uncertainty of that accelerating force. Here is a note you can see. It is easier to use the rule of fractional uncertainty if the question is in terms of absolute uncertainty. Here, as you understand, that the uncertainty plus minus something is the uncertainty of that value, and that value, if it is stated with the unit 0.1 kg, 0.1 meter per second squared, if these things are stated in terms of their unit, then it is what we call as absolute uncertainty. So here the question is stated in terms of the absolute uncertainty for both the masses, for both the mass and acceleration. So while calculating the accelerating force, as we know that the force is just F equals to ma, Newton's second law. So 2 times 2 is 4 Newton. So this is as simple as that. We are going to find out the uncertainty of this force, and we are making use of this fractional uncertainty. What that fractional uncertainty is? It is del F by F, which is equal to del M by M plus del A by A. While calculating the force, we did use the mass and acceleration both. So their absolute uncertainties are also going to be included, but in the form of fractional uncertainty. It is not the way we did for the addition and subtraction. Rather, it is some different method, what we call as the method of fractional uncertainty. And this is the rule of that fractional uncertainty, how to write it down as. So when we are subjecting this del F to find out the absolute uncertainty of force, what we do, we just write the right hand side as it is, and it is going to be multiplied with the force value that we calculated here, 4 Newton. And this del M here is absolute uncertainty of mass, which is 0.1. This is divided by 2, 0.1, the absolute uncertainty of acceleration, divided by 2 again, and it is going to be multiplied with 4. So this is going to be the value of the absolute uncertainty, and this absolute uncertainty here is what we found as 0.4 Newton. So when we are going to express this force, magnitude of the accelerating force with its uncertainty, so this is how we are going to express it. Force plus minus del F means absolute uncertainty of force. It is 4 Newton plus minus 0.4 Newton. So this is how I write down the final expression of this accelerating force with its uncertainty. When it is stated just uncertainty, you can express it in terms of the absolute uncertainty, or you can express in terms of the percentage uncertainty as well. So if you want to find out the percentage uncertainty of this force, so how to draw it, how to get it? So the percentage uncertainty del F is the absolute uncertainty divided by its value multiplied with 100%. This is how we get the percentage uncertainty. The absolute uncertainty, as we already calculated, 0.4, this is divided by 4 times 100%. So it is going to be 10%. So the percentage uncertainty is 10%. Now, if we are going to express the force in terms of the percentage uncertainty in this way, F plus minus percentage uncertainty of F, this is 4 Newton plus minus 10%. The percent does not have an unit, so this is how it is going to be expressed. Okay. Now the thing is that question might not be asked or stated in terms of the absolute uncertainty. If the question is stated in terms of the percentage uncertainty, how to deal with that? So just yes, right here, if you just look at this note, if the question is stated in terms of percentage uncertainty, the rule of percentage uncertainty should be used. And what is the rule of that percentage uncertainty? Well, the two things are in a form of multiplication. So right here, as we know that F equals to MA, this percentage uncertainty of force is just percentage uncertainty of mass plus percentage uncertainty of acceleration. Here, the percentage uncertainty is just going to be added up to get the percentage uncertainty of force. So the same situation, if we just state it in terms of the percentage uncertainty, that is the mass is 2 kg plus minus say 5% as its percentage uncertainty. This is the mass, and acceleration is 2 meter per second squared plus minus 5% as its uncertainty. So the expression is in terms of the percentage uncertainty. If it is in terms of the percentage uncertainty, so this is basically the percentage uncertainty of mass. This is stated. This is percentage uncertainty of acceleration as stated. We are just going to add up the percentage uncertainty of mass and acceleration to get the percentage uncertainty of force, which is 5% plus 5%, and it is 10%. So we have got the percentage uncertainty of the force, which is just 10%. And to get the absolute uncertainty of this force, we just make use of this equation that percentage uncertainty is absolute uncertainty divided by the force value. Right here, since we have calculated the percentage uncertainty, which is 10%, we are going to substitute. So here we are not going to put times 100. So it is not going to be put right here. So the percentage uncertainty of del F we calculated, which is 10%, means 10 over 100. So this 100 what we were putting it to get the value of the percentage uncertainty, this is just coming in the denominator of the left hand side. And this is del F over F. So you say how much del F comes to be. Del F is force times the percentage uncertainty, which is 0.1, and the force we calculated as 4 Newton. You see 2 and 2, the force is mass times acceleration. This is the calculated value of force. So 2 times 2 is 4 Newton. So here we got the 4 Newton times 0.1, which is nothing but 0.4 Newton. So when we are going to express in terms of the absolute uncertainty, we do express 4 Newton plus minus 0.4 Newton like this. When we are going to express in terms of the percentage uncertainty, we express 4 Newton plus minus 10% like this. So when the question is in terms of the absolute uncertainty, we do make use of the fractional uncertainty formula right here. And when the question is in terms of the percentage uncertainty, we do make use of this formula that percentage uncertainty of force is directly percentage uncertainty of mass plus percentage uncertainty of acceleration. If you can just recall the previous videos when we did addition and subtraction part, when the question was stated in terms of the percentage uncertainty, we couldn't add the percentage uncertainty directly when we were doing addition and subtraction. I will request to all of you, please go back, check this video. We didn't add the percentage uncertainty directly when two quantities are in the form of addition or in the form of subtraction. What we had to do there is we had to convert the percentage uncertainty in terms of the absolute uncertainty. And then we had to calculate the absolute uncertainty by just directly adding them up. Just please check those videos, check this one once again, compare these two. You will be understanding the difference, what we did in the addition and subtraction part and what we are now doing for the multiplication part. One thing I additionally would like to say that for the division part, we are going to do the same thing. So for the addition and subtraction, same rule is used. For division and multiplication, same rule is used. So please check it over and over again. If you come up with any question, do ask me, comment right here, and so that I can get back to you with a proper answer. Thank you very much.